using the operations of addition, subtraction, multiplication, and division. We can determine the sum, difference, product, or quotient of two different functions f and g as follows. So if we have f plus g of x, that's equivalent to f of x plus g of x. Similarly, if we have f minus g of x, that's equivalent to f of x subtract g of x. The product of f times g of x is equivalent to f of x times the function g of x. And the division of f divided by g of x is equivalent to f of x divided by g of x, or we could write that as f of x divided by g of x. Now, in determining function values, for example, let's say we wanted to determine f plus g of 5, then using the expressions on the right-hand side can help us with that. So again, for example, f plus g of 5 would be equivalent to finding the function value f at 5 plus the function value g at 5 and adding those two results together. When determining the domain of these combined functions, the domain for all of these combined functions is found by determining the intersection of the two domains of the functions f and g. So what that means is that the domains of these functions is the overlap of the domains of f and g. So in other words, where the functions f and g are both defined, that will be the domain of the combined function. Now there's one exception here, and that's for the quotient of two functions, because here we need to consider when the denominator of this combined function is equal to 0. So here we want to consider when g of x is equal to 0, because we will have added restrictions there. So in other words, for the division of two functions, the domain will be the overlap of the domains of f and g, with the added restriction that g of x cannot equal 0. When we talk about the overlap of the domains of f and g, mathematically, we can write that the domain of, for example, if I take a look at the product here, the domain of f times g would be the domain of f intersected, this is the mathematical symbol for an intersection, intersected with the domain of g. And those of you also taking data management would be very familiar with the symbol for intersection. The symbol for intersection just simply means that any element that is both in the domain of f and in the domain of g would combine to make the domain of f times g. So let's take a look at an example. Here, if we have the functions f of x is equal to log of x and g of x is equal to the square root of negative x minus 5, we're going to determine an equation for f times g of x. So f times g of x, we know can be written as f of x times g of x. And in this case, f of x is log x, and g of x is the square root of negative x minus 5. So the multiplication of those two original functions, f and g, makes up the combined function f times g. If we want to evaluate f times g of 1, we simply either use this combined function that we just came up with to determine f times g of 1, or we could use this type of expression where we write f times g of 1 is equal to f of 1 times g of 1. So because we already have the equation written out here, we can use that equation. So we're going to have log of 1 times the square root of negative 1 minus 5. The log of 1 is equal to 0. And here we get the square root of negative 4. So the square root of 4 is 2. And 0 times 2 is 0. So f times g of 1 is equal to 0. So again, here, if we want to determine f plus g of 1, if we have a combined function already written out, we could use that combined function just as we did in part B. Or another option is to rewrite this as f of 1 plus g of 1, in which case we know f of 1 is log 1, and g of 1 is what we had just determined here. If we substituted 1 into the function g, we got 2. Log 1 is 0 plus 2 gives us a result of 2. Okay, next we're going to use those same two functions, f and g, to determine the domain of f times g of x. So if we look at the domain of the function f, the domain of the function f, well, for a logarithmic function, we know that we can only take the logarithm of a number that is positive. So we need x to be greater than 0. And so we would say the domain of f is all real numbers from 0 to infinity. The domain of g, well, this is a square root function. And so we know for a square root function, we can only take the square root of values that are greater than or equal to 0. So we want the value under the square root to be greater than or equal to 0. And so if we solve this inequality, dividing both sides by negative 1, we remember to switch the inequality sign. And then adding 5 to both sides, we get x is less than or equal to 5, or x is an element from negative infinity to positive 5, including positive 5. So the domain for this combined function is going to be the intersection or the overlap between the domains of f and g, because this combined function, f times g of x, will only exist where both functions f and g exist. So if, for example, at an x value of 100, the function f exists when x is 100. I can take the logarithm of 100. But the function g only exists up to an x value of 5 and not beyond. So I can't take g of 100. I can't find that value. So if I can't find a value for g of x, then I can't find a value for f times g of x. So I only want the domain to be the overlap between the domain of f and g. So here, the domain of f times g is the overlap of these two. Now these two overlap from 0 to 5, including 5. So we say the domain of f times g is from 0, not including 0 because we can't take the logarithm of 0 here, up to positive 5. Now, if in this question we were instead looking at a quotient of two functions, so f divided by g of x, then we would also want to consider when the function g of x is equal to 0, because the combined function would be undefined there. And so the function g of x would be equal to 0 at x equals 5. And so in that case, we would not want to include that x value of 5 in the domain of f divided by g. So I'll write that one out as well. So the domain of f divided by g would still be the overlap of the domains of f and g, except we do not want to include that value of 5, so we use an open bracket here for interval notation, because g of x would be equal to 0 when x equals 5. So we can't have that function g being equal to 0 because it's in the denominator here, and we know we can't divide by 0.